Settle in and let go. There's nowhere you need to be and nothing you need to hold on to. Somewhere far from here, we'll drift down toward a strange shape, resting silently on the Baltic Sea floor. Should this help you fall asleep, subscribe, and I'll have another for you tomorrow. In June of 2011, a survey vessel belonging to the Ocean X team moved at a steady working pace across the northern Baltic Sea, its hull low and purposeful against the flat gray water, its sonar equipment trailing below the waterline in the cold dark where the light had long since given out. The sea in that region in June carries a particular quality of silence, not the silence of absence, but the silence of a large body of water that has been crossed by vessels for 1,000 years, and that receives each one without comment. The ship's engines held their note. The sonar unit sent its pulses downward, 85 meters into the cold, and received them back, and the equipment translated what came back into a continuous acoustic map of the seafloor below, line by careful line. Peter Lindbergh had been working in the Baltic for many years before that summer. The Ocean X team, the commercial salvage and exploration operation he ran with his business partner Dennis Osberg, had developed a working knowledge of what the Baltic seafloor looked like in sonar return. The sediment plains, the scattered formations, the occasional wreck, the accumulated debris of centuries of maritime activity in one of Europe's most heavily trafficked seas. A side-scan sonar survey in the northern Baltic was a professional activity, structured and methodical, the vessel moving in planned transects above the seafloor, while the equipment below gathered its acoustic data, and the system above rendered it into images. It was not romantic work. It was technical work, the kind performed by experienced people who had done it many times before and who understood its instruments and its outputs with the specific familiarity of long practice. The expedition that summer was commercial in its purpose. The Ocean X team was searching for historically documented shipwrecks, vessels known to have gone down in the region carrying cargo of documented value, the kind of target that had drawn Baltic salvage operations for generations. The northern Baltic holds a large archive of maritime loss, trading ships, warships, fishing vessels, the ordinary attrition of centuries of navigation through a sea that could be reliably difficult. Lindbergh and Osberg were looking for something specific. The sonar was the tool that would find it, sweeping the seafloor in slow acoustic arcs, building up a map of what lay below the hull, section by section, across a working day. The survey work proceeded as it always did. The vessel held its heading. The sonar continued its quiet operation. The seafloor came back in its acoustic colors, the gray tones of reflected sound, distinguishing sediment from stone, flat plain from raised formation, the unremarkable topography of the northern Baltic accumulating on the display screen in the specific visual language of sonar imagery. There was nothing, and then there was something. The sonar return from one area of the seafloor produced a shape that did not look like what the surrounding seafloor looked like. It was circular. It was large. It sat on the flat sediment with a degree of symmetry that drew the eye even in the compressed two-dimensional language of acoustic mapping. Lindbergh, in later accounts, described looking at the image and finding that it did not resolve into any standard category of thing he had seen before in his years of Baltic sonar work. Not a wreck which tended toward linear or irregular forms. Not the scattered debris fields that mark old maritime lost sites. Not the geological features he had encountered across seasons of surveying the Baltic seafloor. The shape that had come back from the sonar was circular in a way that the seafloor beneath the northern Baltic was not generally circular, raised in its center in a way that suggested a dome or mound structure, and defined at its outer edges in a way that gave it what the sonar image appeared to show as a rim. He stated publicly that he had not encountered anything quite like it in his years of Baltic work. The vessel held its position above the site. The data continued to arrive. The depth at which the object sat was approximately 85 to 90 meters below the surface, the kind of depth that presents real challenges for dive operations, but is within the working range of experienced technical divers equipped for cold, dark water. The location Lindbergh and Osberg placed the object was in the northern Baltic Sea, in the region between Sweden and Finland, near the entrance to the Gulf of Bothnia, a stretch of water that is neither shallow nor simple, that carries significant temperature gradients with depth, and that offers very little light at any meaningful depth in any season. The precise coordinates of the site were withheld by Ocean X Team following the discovery, a decision described by the team as protecting the location from competing salvage operations, a standard practice in commercial maritime exploration when a potentially significant discovery has been made but not yet fully investigated. The sonar image itself was a two-dimensional acoustic rendering, the kind of image produced by side-scan sonar technology operating under the conditions of that particular stretch of seafloor. The image showed, in the gray tones of reflected sound, a circular form sitting on what appeared to be a flat sediment plain, with its raised center distinguishing it from the surrounding topography and its outer edge forming a defined boundary. The image was not a photograph. It was a map made of sound, or more precisely, a map made of the way sound bounced back from surfaces at depth, translated by the sonar system's software into a visual representation that a human eye could read. The limitations of that process were real and well understood. Side-scan sonar in sediment-rich Baltic conditions could produce visual artifacts and shadow effects. Naturally occurring geological formations could appear in sonar return, more symmetrical and geometrically regular than they were in three-dimensional physical reality. An experienced sonar interpreter approached a single sonar image with these limitations in mind, and a careful one would note them before drawing conclusions. What Lindbergh noted publicly was that the image was unusual enough in its apparent symmetry and circular form that he did not immediately have a standard explanation for it. He was careful to describe it as something unexpected within the context of his Baltic experience, rather than to claim that it could only be explained in extraordinary terms. The observation was genuine. The caution was also genuine. The image sat on the sonar system's display, the vessel above it, in the flat gray water of the northern Baltic in June, and whatever was below, whatever had returned that shape to the sonar, sat in the cold at 85 to 90 meters, as it had apparently sat for however long it had been there. The Ocean X team's decision to release the sonar image publicly came in late 2011. The image moved through press channels with a speed that the team may not have fully anticipated, given the particular quality of that specific historical moment in media, the early years of global social media, when a striking image with an open question attached to it could travel from one language and one continent to another within a span of hours. By the time the image had been reproduced across international news platforms, it had acquired a specific cultural shape. The language attached to it in news coverage was often dramatic. Words like alien and otherworldly appeared in headlines and article bodies across European and North American outlets. The image reproduced in black and white across newspaper front pages and news websites carried its own visual authority, a disc-like form, pale against a dark background, sitting at the bottom of a featureless plain, the kind of shape that required some effort to categorize as ordinary, and very little effort to categorize as extraordinary. Lindbergh addressed the coverage in public statements. He described the object as something he could not immediately account for through standard geological reasoning, a position that was careful and honest given what the sonar data actually showed. He was not, in those early statements, claiming a specific identity for the object. He was stating that the shape was unusual, that it had caught his attention in a way that the ordinary returns of many seasons of Baltic sonar work had not caught his attention, and that he intended to find out more. The image continued to move. The international news cycle of late 2011 had many things in it, and the Baltic sonar image held its own within that cycle with a particular persistence, the kind that attaches to a genuine open question, something that had been found in a real place by real people, doing real work that had not yet been explained, and that carried enough visual strangeness to sustain continued attention. Millions of people encountered the image in the days and weeks following its release. The sonar picture of the anomaly, that two-dimensional acoustic rendering of a circular form with an apparent raised center and defined outer edges, moved from news website to news website, from social media platform to social media platform, from language to language, reproduced in the specific gray tones of reflected sound, in contexts ranging from serious science journalism to deeply speculative online discussion. A single image made of sound, produced on a working day in the northern Baltic by the trailing sonar equipment of a commercial salvage vessel, had become in the space of a few days something that millions of people were sitting with, studying, discussing, and carrying forward with them. The Baltic Sea anomaly, as it came to be known, had entered the world. The ocean that held it was not a dramatic place in those late months of 2011. The northern Baltic is a working sea, a body of water with a long and practical relationship with the people who live around it, a trade route and a fishing ground, and a military waterway, and a crossing. In summer, the surface is gray, more often than blue, the sky above it wide and Nordic, the horizon visible in all directions from the deck of a vessel running a sonar survey. There was nothing theatrical about the conditions that produced the discovery. A ship, a sonar system, a working team of experienced maritime professionals, a stretch of seafloor at 85 meters depth, the specific acoustic return of a circular shape from a flat sediment plain, rendered on a display screen in the ordinary visual language of sonar imagery. The vessel itself was a working boat, outfitted for commercial maritime operations rather than for research or exploration in any formal scientific sense. Ocean X Team was a commercial enterprise operating in the tradition of Baltic salvage and maritime exploration that had produced numerous legitimate recoveries of historically significant wrecks and their cargoes over many decades. Lindbergh's background was in this world, the practical, equipment-heavy, commercially structured world of deep-sea salvage, where sonar was a tool for finding things, and where the ability to read sonar imagery was a professional skill developed over years of working in the particular conditions of the Baltic. When he described the anomaly as something he had not encountered before, that description carried the weight of his accumulated experience of Baltic sonar returns, which was considerable. Dennis Osberg, his business partner in Ocean X Team, shared the discovery. The two men had built their commercial operation together, and the decision to pursue the anomaly and subsequently to release the sonar image publicly was a joint one. Their accounts of the discovery and the decision to go public were broadly consistent with each other in the press coverage that followed. Two working people who had found an unusual sonar return on an otherwise routine survey day, and who, after some consideration, had decided that what they had was worth sharing with the wider world. The decision produced consequences neither man could have fully predicted from the deck of a vessel in the northern Baltic in June of 2011. The coordinates were withheld. The image was released. The world took the image and ran with it in every direction. What happened in the sonar that day, the moment when the circular shape first resolved on the display screen, is not something anyone documented in real time with the kind of detail that would allow a precise reconstruction. Lindbergh described it after the fact, in interviews and public statements, and those descriptions emphasize the moment of recognition, looking at the return and finding it unusual, finding it without a ready category, finding that the years of Baltic sonar work behind him did not provide an immediate frame into which this particular shape fit. That experience of not immediately recognizing something is a very ordinary human experience in an unusual professional context. It is the experience of encountering something the pattern recognition system does not immediately match, and it carries a specific quality, a kind of quiet pause, a second look, a moment of genuine puzzlement that is neither alarming nor certain, simply the honest registration of an unexpected thing. The sonar equipment was functioning normally. The vessel was performing its survey in the standard way. The seafloor below was what it had always been, present, cold, 85 meters down, shaped by whatever had shaped it, holding whatever it held. The shape returned from it was the shape it had apparently always had, or at least the shape it had on that particular day, in June 2011, when the Ocean X team's sonar passed over it and translated its surface into acoustic return. There was no drama in the physical event itself. The strangeness was in what the image showed, or appeared to show, and in what that appearance did and did not correspond to in the accumulated knowledge of Baltic sonar work that Lindbergh and his team brought to the screen. The survey continued after the anomaly was noted. The team's work in the northern Baltic that summer had objectives beyond the single unusual return, and a commercial expedition did not pause indefinitely to study a single anomalous sonar image. The data was recorded, the location was noted, the coordinates were logged, and then the vessel moved on, as vessels do, continuing its survey of the seafloor in the gray Baltic light of a June day. The equipment trailing below in the cold water, the seafloor continuing to return its acoustic maps, most of them unremarkable, the single remarkable return sitting in the data record, waiting for what came next. What came next, in the weeks and months that followed, was the decision to go public. The decision to release the image was not, from the documentary record, a sudden or unconsidered one. Lindbergh and Osberg discussed the anomaly and what to do with it. They were commercial operators, and the anomaly had potential value, not necessarily as a salvageable object, since its nature was entirely unclear, but as a discovery that might attract attention, funding, and public interest in their operation. The release of the image through press channels was a deliberate act. It was the act of two people who had found something genuinely unusual, who did not have an explanation for it, and who decided that the wider world's attention on the thing was more valuable than keeping the thing to themselves. The image went out. It arrived in newsrooms across Europe in the final weeks of 2011, a period when the international news cycle was busy with other matters, and found within that busy cycle a specific kind of purchase. A sonar image of an apparently circular object at the bottom of the Baltic Sea was the kind of discovery that fit naturally into a growing media appetite for deep ocean mystery, the kind of story that combined the genuine authority of a documented discovery by real professionals with the open-ended possibility of an explanation not yet provided. The coverage varied in its register from careful to sensational, as coverage of unusual discoveries always does. Some outlets described the object with scientific caution, others ran with the extraterrestrial framing immediately, printing the image under headlines that placed alien origin as the central possibility rather than one among many. Lindbergh, in his public statements at that stage, did not endorse the extraterrestrial framing. He described the object as unexplained in his experience, noted that he intended to return to the site for a closer look, and declined to speculate about what the object was. This was a measured position, and it was reported with varying accuracy by outlets whose appetite for the story ran ahead of the detail of what he actually said. The gap between what Lindbergh stated and what some outlets reported him as implying was a gap that the story would carry forward. The distance between a careful description of an unusual sonar return and the extrapolated possibility of something from outside the ordinary world sitting at the bottom of the northern Baltic Sea. The image itself, once in circulation, developed its own momentum, reproduced in black and white. The acoustic rendering of the circular form carried a visual authority that photographic evidence often lacks because it looked like a technical document, like the output of professional equipment, like something produced by a machine rather than by human hands. The two-dimensional acoustic map of the Baltic seafloor, with its disc-like anomaly sitting at the bottom of the image, did not look like a photograph that could be altered or composed or misrepresented in the ways that photographs can be. It looked like data. That appearance of being data gave it a specific kind of credibility in public perception, even though the interpretation of sonar data requires a specialist knowledge that most of the people encountering the image did not possess. What a sonar image looked like to a non-specialist eye was not necessarily what it described to a trained one. The northern Baltic seafloor, in the region where the anomaly sat, has a long geological history and a complex topography. It has been shaped by forces operating over periods far longer than the span of human civilization in the region. The advances and retreats of ice sheets, the deposition of sediment across millennia, the slow processes of seafloor formation that have no human scale to them. It is a complex environment, documented in detail by marine geologists who have spent years mapping it, and it contains an enormous variety of natural formations, some of which carry, in sonar return, shapes that a non-specialist eye might not immediately recognize as naturally occurring. This was the context into which the anomaly's image arrived. The seafloor was not a featureless blank. It was a documented environment with a well-understood formation history, and whatever sat at 85 meters in the northern Baltic, whatever had produced that circular sonar return, sat within that history, whether it was part of it or not. The news coverage of late 2011 largely did not engage with this context. The geological background of the northern Baltic seafloor is not the kind of detail that drives news coverage of an unusual discovery. The headline was the shape, the disk, the dome, the rim, the symmetry, the context in which that shape sat, the natural history of the region, the limitations of side-scan sonar interpretation, the existence of naturally occurring circular seafloor features throughout the Baltic was present in some of the more careful coverage, but absent from much of it. The image moved faster than the context, as images tend to do, and arrived in millions of people's awareness, stripped of most of what would help them assess it accurately. By the close of 2011, the Baltic Sea anomaly had acquired the specific cultural status of a documented mystery, something real, something found by identifiable people with professional credentials, something visible in a recorded image, and something for which no widely accepted explanation had been publicly established. That status was genuine in some of its components and constructed in others. The discovery was real. The sonar image was real. Lindbergh's description of the image as unusual within his Baltic experience was real. What was constructed, or more precisely, what was assembled in the gap between what the image showed and what it could be said to prove, was the sense that the lack of an immediate explanation constituted a mystery requiring extraordinary options. The distance between an unusual sonar return and an extraordinary conclusion was a large one. In the late months of 2011, millions of people traversed it very quickly. The vessel that found the anomaly was not a research ship. It had no scientific affiliation, no institutional mandate, and no obligation to subject its findings to peer review or independent verification before releasing them publicly. Ocean X Team was a private commercial operation, and the discovery it made and the image it released were its own to manage as it saw fit. This is not a criticism of the team's conduct. It describes the structural reality of the discovery's origins, which shaped everything that followed. A discovery made by a commercial salvage operation and released through press channels enters public awareness through a different pathway than a discovery made by a research institution and published in a scientific journal. It reaches more people more quickly. It encounters less systematic scrutiny before it establishes itself in the cultural record. It can be shaped in its presentation by considerations that scientific publication does not permit. What the image showed, in the plain, measured terms of what side-scan sonar imagery can establish, was a circular feature on the Baltic seafloor at approximately 85 to 90 meters depth, with apparent raised central structure and defined outer edges, sitting on what appeared to be a flat sediment plain in the northern Baltic between Sweden and Finland. That is what the sonar image showed. What the sonar image did not show, what sonar imagery in those conditions could not show, was the three-dimensional form of the object, the composition of its surface, the nature of its relationship to the seafloor around it, or any of the information that would be necessary to move from the image to a conclusion about what the object actually was. The image was interesting, it was unusual, it was documented, and it was, in the end, a starting point rather than an answer. In the days immediately following the image's release, the same acoustic rendering, the pale disk on the dark background, the apparent rim, dome, the surrounding flat sediment, appeared in dozens of languages on the front pages and interior sections of newspapers across Europe and North America, on news websites in countries where the Baltic was a distant body of water with no particular personal resonance, on social media platforms where it was shared and reshared and discussed and speculated over by people who had no more information about the object than the image itself provided. The image was singular, and it was everywhere at once. It crossed into languages in which the words for seafloor and sonar and anomaly were rendered in entirely different scripts. It sat on the screens of people who had never thought about the northern Baltic Sea before and would not think about it again. It was attached to headline language, ranging from the precise and hedged to the unconstrained and speculative. In some languages, it appeared under headlines that translated roughly to mysterious disk found on Baltic seafloor. In others, the headlines gestured more openly toward visitors from outside the ordinary world. In all of them, the image was the same pale acoustic rendering, the same circular form, the same apparent raised center, the same featureless plane around it, the same gray tones of reflected sound that Peter Lindbergh and Dennis Asberg had looked at on the display screen of their survey vessel, somewhere in the northern Baltic on a working day in June. The image that a side-scan sonar system had drawn from the echoes of sound pulses sent down through 85 meters of cold Baltic water had, within the span of a few days, become one of the most widely viewed single images produced by an ocean survey in years. It had established itself with a speed that no scientific paper and no formal research announcement could have matched in the public record as something worth examining, as a shape in the water that deserved continued attention, that had not yet been satisfactorily explained, and that would continue to generate questions for a long time to come. The object at 85 meters had not moved, the sea above it had not changed, but the world's awareness of it had shifted entirely, and that shift, once made, proved permanent. The sonar image continued to circulate. Months passed, and it was still circulating. A year passed, and it was still circulating. The shape of the anomaly, the disk, the dome, the rim, the trail, the flat sediment plain of the northern Baltic, had embedded itself in the particular genre of documented mystery that persists not because its central question has been answered, but because the question itself is interesting enough to return to. A shape found at the bottom of a cold sea by two working people on a routine survey day in June. The Baltic went on above it. The image went on across the world below. 60 meters. That single measurement, drawn from the acoustic return of the Ocean X team's sonar equipment in the northern Baltic Sea in June 2011, is the number that anchors everything else the team reported about the object on the seafloor. 60 meters across. Not a rough impression, not an approximation described in casual terms. A figure that Peter Lindbergh and his colleagues extracted from analysis of the recorded sonar data and placed into their public description of the site with the specificity of a working measurement. It is worth understanding, before moving to any other characteristic the team described, what 60 meters actually means as a physical scale. The wingspan of a Boeing 747, the wide-body commercial aircraft that has been crossing the world's oceans for decades, runs to approximately 68 meters. The object reported on the Baltic seafloor, if the sonar measurement holds, sits within a few meters of that span. That is not a boulder. That is not an isolated rock shelf. At the diameter Ocean X team reported, the object would fill a substantial portion of a commercial aircraft hangar, and it would do so on a flat, sediment-covered seafloor at approximately 85 meters of depth, in a part of the Baltic Sea that no diver or submersible had, by the team's account, previously examined with any care. That 60-meter figure was not independently verified by external scientific analysts at the time Ocean X team made it public. This is not a small qualification. The figure came from the team's own reading of their own sonar data, using their own analytical process, and no institution with independent access to the raw sonar recordings produced a separate measurement, confirming or adjusting that number during the period of initial public interest. The measurement persists in the public record because Ocean X team reported it, and the press repeated it, not because it was checked against a second dataset by a second team. The distinction between those two things, a reported measurement and a verified one, does not make the figure wrong. It simply marks it for what it is, a claim derived from a particular dataset by the people who collected that dataset, carrying the weight of that provenance, and no more. Side-scan sonar, the technology the Ocean X team used to survey this stretch of Baltic seafloor, works by emitting pulses of acoustic energy from a sensor typically towed behind a survey vessel. Those pulses travel outward and downward from the tow unit, strike the seafloor and anything resting on it, and return to the sensor as echoes. The system records the strength and timing of each returning echo and builds from that data a two-dimensional image, not a photograph, not a topographic map in the conventional sense, but an acoustic rendering in which the brightness of any given point corresponds to how strongly that point reflected sound back toward the sensor. Hard surfaces return strong echoes and appear bright. Soft sediment absorbs more energy and returns weaker echoes, appearing dark. Features that rise above the surrounding floor intercept the outgoing pulse at an angle that produces a characteristic shadow behind them, a darker region in the acoustic image where the floor was hidden from the sensor's line of acoustic sight. That shadowing effect is fundamental to how side-scan sonar generates the impression of three-dimensional form in a two-dimensional image. The bright return from a raised feature and the dark shadow it casts together create the impression of height and shape. Marine geologists who work routinely with Baltic sonar surveys have noted that this process, reliable and well understood as it is, carries a specific set of limitations in sediment-rich environments like the northern Baltic. Fine suspended particles in the water column can scatter acoustic energy in ways that reduce image clarity. The geometry of the tow path relative to the target affects the shadow angle and thus the apparent shape of the feature being imaged. Features with naturally irregular surfaces can return acoustic patterns that suggest more regular geometry than the physical surface actually has. None of these limitations mean that side-scan sonar is an unreliable tool. It is one of the core instruments of modern marine surveying, and its imagery has documented thousands of wrecks, geological formations, and seafloor features with considerable precision. The limitations simply mean that a sonar image is an interpretation of acoustic data, not a direct visual record, and that the apparent geometry of a feature in a sonar image needs to be held with some awareness of how that geometry was produced. The sonar image that Ocean X team released to the press showed a circular feature approximately 60 meters in diameter as the team measured it, with a raised perimeter and a central section sitting above the surrounding seafloor level. The raised outer edge gave the image a rim-like quality, a brighter ring enclosing a slightly elevated interior, and it was this combination of circular outline and central dome that produced the visual impression most widely reproduced in media coverage. The dome description came from the way the acoustic return brightened toward the center of the circular feature, consistent with a surface that curved upward from its edges to a higher central point. The rim appeared as a well-defined boundary between the raised structure and the flat acoustic background of the surrounding seafloor. Together, these elements created the impression, and it is important to carry the word impression carefully here, of a disc-shaped object with measurable vertical relief sitting on an otherwise unremarkable stretch of Baltic sediment. The 300-meter linear feature was the second major element in the sonar image, and it drew almost as much attention as the circular form at its terminus. Extending away from the circular object across the seafloor and running for a documented distance of approximately 300 meters, this linear marking appeared in the sonar data as a narrow, consistent groove or depression running in a roughly straight line away from the main feature. Ocean X team described this marking as a trail, and the word carried with it an implied interpretation. Something had moved, something had come to rest, and the line extending from its current position marked the path it had traveled. The team described the linear feature as consistent with a skid mark, the kind of displacement that would result from an object traveling across the seafloor before losing momentum and stopping. That interpretation required several assumptions, primarily that the linear feature and the circular object were causally connected and not merely adjacent by proximity, and that the linear feature represented directional travel rather than some other geological process that produced a similar acoustic signature. Neither assumption was assessed as unreasonable on its face. Neither was, at the time of the initial announcement, independently evaluated against the raw sonar data by an external analyst. 300 meters is a specific distance in physical terms. Walking it at an unhurried pace takes perhaps 3 or 4 minutes on level ground. In a sonar image of a flat seafloor, 300 meters of linear marking is a substantial feature, long enough to be unmistakable in the acoustic record, long enough to be clearly associated with whatever lies at one end of it, and long enough that its origin and nature become a genuine analytical question rather than a peripheral detail. If the linear feature is a glacial scour mark, its dimensions are consistent with many such marks documented elsewhere on the Baltic seafloor. If it is a displacement trail, its dimensions are consistent with the kind of travel distance a large, dense object might cover when moving across soft sediment under conditions that gradually absorbed its momentum. Both readings of the same 300-meter line are physically plausible. The sonar image alone does not settle which reading is correct. The depth of approximately 85 to 90 meters places the site well into the range that sport divers do not reach, and that even technical divers approach with considerable preparation. Water at 85 meters in the northern Baltic is not simply deep, it is cold in a way that compounds every other challenge of the dive. Baltic Sea temperatures at that depth run well below 5 degrees Celsius in most conditions, a cold that saturates neoprene suits, reduces dexterity in gloved hands, and shortens the window of effective working time for divers managing their air and decompression obligations simultaneously. Visibility at that depth in Baltic conditions is limited by the combination of low light penetration through 85 meters of water column and the particulate matter, fine suspended sediment, algae, organic debris that the Baltic holds in suspension throughout its middle and deeper water layers. A diver's torch at that depth illuminates a cone of perhaps a meter or two in useful detail before the beam is scattered by suspended material, and beyond that cone the water is close to black. These conditions do not make the site impossible to reach. They make it genuinely difficult, time-constrained, and physically demanding in ways that have concrete consequences for the quality and quantity of observation a diver can perform once at the bottom. The sonar data itself does not directly tell an observer how deep the anomaly's raised features extend above the surrounding seafloor. The acoustic return provides relative brightness information, how strongly each point reflected sound, and the shadowing geometry provides an indirect indication of vertical relief. But translating acoustic shadow dimensions into precise height measurements requires careful geometric calculation and knowledge of the exact toe geometry during the survey pass. Asian X Team did not, in their public descriptions of the site, release detailed height measurements for the raised rim or the central dome derived from that kind of geometric analysis. What the sonar image conveyed was the impression of vertical relief, the raised edge, the domed center, without a precisely documented figure for how far above the ambient seafloor the highest point of the structure rose. This is worth noting, not because the absence undermines the claim of a raised feature, but because it marks one of the several places in the reported data where the precision runs out and approximation takes over. The 60-meter diameter, the raised rim, the central dome, the 300-meter linear marking, these four characteristics form the core of what Ocean X Team documented and described from the sonar survey. Each of them appears in the sonar image the team released. Each of them was described by the team using language that remained technically attributable to what the acoustic data showed, even as the combination of characteristics invited interpretive leaps that went well beyond what sonar data by itself can establish. The rim and dome reading of the sonar return describes a genuine feature of the acoustic image. The brightness pattern and shadow geometry are consistent with a raised circular form, but acoustic consistency is not the same as geometric conformation. The sonar shows something. What that something is at the level of material fact, at the level of what a diver's hand would feel and an engineer's eye would see, is a question the sonar image cannot answer on its own. It is useful to hold alongside the sonar image a concrete sense of what the Baltic seafloor in this region actually holds as a matter of documented geological record. The northern Baltic sits within a territory extensively reshaped by the Vixolian glaciation, a period of glacial advance and retreat that ended approximately 10,000 to 12,000 years ago and left behind a seafloor strewn with glacially deposited material, boulders transported from distant geological formations, scraped and deposited by moving ice, moraines of accumulated glacial debris, and irregular mounds and ridges where ice margins once sat and released their sediment load as the temperature shifted. Circular and dome-shaped features appear throughout the documented acoustic record of Baltic seafloor surveys. Products of these glacial processes, as well as other natural mechanisms, including the formation of sedimentary concretions, dense mineral aggregations that grow around nuclei, sediment-rich environments, and can achieve sizes and shapes that produce sonar returns, strongly resembling the characteristics Ocean X team described. The Baltic seafloor at the latitude of the Anomaly site is not a blank plain. It is geologically complex, acoustically varied, and documented to contain precisely the kinds of irregular, raised, bounded features that would generate the class of sonar return the Ocean X team image represents. This context does not resolve what the Ocean X team found. It places it within a landscape. The landscape is relevant because the sonar image alone, a single acoustic survey pass, producing a two-dimensional rendering of one segment of seafloor, cannot be read in isolation from the broader geological character of the environment it was collected in. A feature that would be anomalous on a perfectly flat, geologically simple seafloor is a different kind of finding from a feature of the same dimensions and characteristics encountered on a seafloor where similar features have been documented at multiple sites. The northern Baltic belongs to the second category. That belonging neither confirms nor eliminates the anomaly's claim to being something other than geology. It is simply part of the accurate picture of what the sonar data was being generated in the middle of. The specific resolution limitations of side-scan sonar in Baltic conditions came up repeatedly in the commentary of marine geologists and sonar specialists who addressed the image publicly after its release. A key point in their assessments was that the contrast between the circular features' apparently sharp, regular perimeter and the flat surrounding seafloor, which gave the image much of its striking quality, was not necessarily a true representation of the feature's physical geometry. Side-scan sonar shadow geometry can create the impression of a well-defined edge around a raised feature, even where the physical transition between the raised structure and the surrounding floor is gradual or irregular. The rim-like quality of the anomaly in the sonar image, in other words, may reflect the properties of the acoustic imaging process as much as it reflects the properties of the feature itself. This is a well-understood characteristic of side-scan sonar systems, not a speculative critique invented for this particular case. It applies whenever a raised feature with moderate vertical relief is imaged in the presence of soft sediment surroundings, which describes exactly the conditions under which the Baltic anomaly sonar image was collected. The released sonar image was a black and white acoustic rendering, approximately square in proportion, with the circular feature positioned slightly off-center on the frame. The surrounding seafloor appeared as a relatively uniform dark field, with minor acoustic texture, the ordinary undramatic return of flat sediment, against which the brighter circular form sat in clear contrast. The 300-meter linear feature extended from the circular form toward one edge of the image frame, in a line that remained consistent in width and brightness for most of its length before fading toward the image edge. The image had the characteristic grain and soft-edged quality of acoustic data displayed at the resolution typical of commercial side-scan systems, not a sharp photograph, not a blurry one, but the specific textured quality of sound rendered as picture, in which some details are clear and others exist at the threshold of what the data can support. This image, this particular two-dimensional acoustic rendering, is the primary piece of physical evidence that the public record of the Baltic Sea anomaly ultimately rests on. The dive accounts, the recovered samples, the competing descriptions of what the seafloor surface looked and felt like, all of that came afterward. The sonar image came first, and it is what established the shape of the question before anyone descended to examine it. Ocean X Team did not hold the raw data exclusively in the period following the initial release. The sonar image was reproduced widely enough that analysts with experience in acoustic survey imagery were able to offer public assessments based on the released picture, even without access to the underlying dataset. The assessments that emerged from those analysts were largely consistent with one another and with the broader geological context of the northern Baltic. The features visible in the image were described as within the range of naturally occurring seafloor geology, interesting in the sense of being an unusually well-defined example of a formation type common to glacially influenced seafloor environments, but not requiring explanation beyond that framework. These assessments did not carry the institutional weight of a formal peer-reviewed analysis. Neither did the Ocean X team's own reported measurements. Both occupied the space of expert commentary on publicly available evidence, which is a different and more limited thing than a formal scientific investigation of the raw data itself. What persists in the documented record, then, is a sonar image of a large circular raised feature on the northern Baltic seafloor, approximately 60 meters in diameter by Ocean X Team's measurement, with a rim-like perimeter, a domed center, and a 300-meter linear feature extending from its edge across the surrounding seafloor. Those characteristics are the documented content of the image. The image was collected by a commercial salvage team using standard survey equipment in a region of the Baltic Sea known for complex glacial geology. The image was not independently analyzed by a scientific institution with access to the raw sonar data. The site at which the image was collected lies at approximately 85 to 90 meters of depth, in conditions that impose significant physical constraints on direct examination. These are the contours of what is actually known from the sonar phase of the Ocean X team's documentation of the site. They are specific and they are real, and they are also limited in the particular way that a single sonar pass, analyzed by the team that collected it, is always limited, not because that process is dishonest, but because it is incomplete in ways that only independent analysis or direct physical investigation could address. The linear feature extending 300 meters from the circular form is the element of the sonar image that is perhaps most easy to hold as a concrete picture. Imagine the sonar display screen aboard the Ocean X team vessel, the circular form sitting in the acoustic gray of the seafloor, and then the line, a narrow, consistent dark marking running straight away from the circle's edge for the distance that at the vessel's scale would take a full minute or more to traverse at walking pace. At the scale of the seafloor image, 300 meters is a long and clear mark. It does not fade and reappear. It runs in a consistent direction without obvious interruption, and its presence in the same sonar return as the circular form made the two features feel connected in a way that no other feature in the surrounding acoustic field was connected to them. An isolated circle and a line leading away from it, the two together creating the compositional logic that the image then carried into press coverage and public interpretation. That compositional logic, circle, line, implied movement and rest, was the visual grammar that made the sonar image feel like an explanation waiting to be written rather than simply a piece of uninterpreted acoustic data. It is worth recognizing that the grammar and the explanation are different things. The image suggested a story. The story was not established by the image. The equipment that produced the image continued trailing through the cold water of the northern Baltic after the survey pass over the Anomaly site was complete. The vessel moved on. The sonar pulses continued their work across other stretches of seafloor, returning echoes of sediment and rock and the ordinary geography of the Baltic bottom. The image of the circular form was stored in the data record of the survey. It sat there through the remaining weeks of the expedition, through the return to port, through the months before Ocean X team released it publicly in late 2011. During that waiting period, the seafloor, at approximately 85 to 90 meters of depth, remained exactly as the sonar had captured it. Cold, dark, undisturbed, the circular feature and the long line extending from it as they had been when the acoustic pulses first found them, neither more nor less than what the sound had returned. The sonar system itself was a production tool, not a scientific instrument designed for the specific purpose of characterizing anomalous seafloor features. Commercial side-scan sonar units of the type routinely used in salvage survey work are optimized for the task of identifying objects of salvage interest, wrecked structures, cargo debris, anchor chains on the seafloor at operational depths. They are effective at that task. They are less well suited to the task of precisely characterizing the three-dimensional geometry of features whose identification depends on subtle distinctions between, for example, naturally fractured rock and artificially shaped material. The resolution that would allow an observer to make that distinction from sonar data alone is not what commercial survey equipment is designed to deliver, and the Baltic conditions at 85 meters of depth do not improve on the resolution that the equipment is capable of in ideal conditions. None of this means the image is inaccurate as a representation of what the sonar actually recorded. It means that what the sonar was designed to record and what would be needed to answer the questions the image generated are not fully overlapping things. One other feature noted in Ocean X Team's description of the sonar data was a report of what appeared to be a flat or step-like surface on part of the Anomaly's visible profile, a section where the acoustic return suggested a horizontal or near-horizontal surface rather than the curved geometry of the dome. This detail appeared in some of the team's public descriptions of the image, but was less consistently cited than the circular form, the rim, or the linear feature, and it received less attention in press coverage than those primary characteristics. Its presence in the record is worth noting simply because it added to the reported irregularity of the object's surface profile. The suggestion that the feature was not a simple smooth dome, but had some degree of internal structural complexity, visible even in the acoustic data. Whether that complexity reflects natural fracture patterns in rock, glacial compression and deposition, producing irregular layering, or some other process, is a question the sonar data alone did not resolve and was never in a position to resolve. 60 meters across, a raised rim, a domed or elevated center, a flat or angular section on at least part of the profile, a 300-meter linear feature extending from the edge, approximately 85 to 90 meters of depth in the northern Baltic Sea, in water that is cold, dark, particulate dense, and physically demanding in ways that constrain what any observer can do with the limited time that decompression requirements allow at that depth. A side-scan sonar image collected on a single survey pass by a commercial salvage team and analyzed by that same team without independent verification of the reported measurements. These are the coordinates of the documented evidence, held exactly as the evidence presents them, no more precisely than the data supports, no wider than the acoustic frame of the image they came from. The sonar unit that produced this image trailed through the water at depth in the quiet of a long Baltic survey day, sending its pulses down and receiving its echoes back, translating each return into a point of brightness or shadow on the accumulating acoustic picture. The mathematics of the conversion was reliable in the way all well-understood physics is reliable. The image it made was real in the way that acoustic data is real. What the image showed was a shape in the sediment, a particular, specific, measurable shape, sitting on the floor of a cold northern sea, surrounded by the flat acoustic background of ordinary Baltic geology. The shape was real. Its dimensions, as the team reported them, were specific. And the question of what the shape was, what physical process made it, what material composed it, what history it held in the rock or sediment or substance of its structure, was a question that the sonar image, for all the precision of the physics that produced it, was not able to answer. That question sat in the data like the shape itself sat in the sediment, still, particular, and patient, waiting for a kind of attention that the acoustic return alone could not provide. The image it made, sitting in the record in the years that followed, unverified, unreplicated, and carrying in its gray and white tones the specific ambiguity of sound translated into shape across 85 meters of cold, dark northern water. In June of 2012, the Ocean X Team vessel moved slowly across the northern Baltic Sea toward a set of coordinates that the team had held quietly for close to a year. The water that morning was cold and flat, in the way that the Baltic is cold and flat in early summer, a gray-green surface that does not suggest what lies beneath it. On the deck, equipment was being sorted and checked. Dive gear was laid out in rows, tanks inspected, regulators fitted, and tested in the particular methodical way of people who descend to depth for a living and know what untested equipment costs. The preparation had its own rhythm, unhurried and careful, and the sound of it, the clinking of hardware, the low mechanical check of valves releasing and closing, carried across a deck that was otherwise quiet, with the ordinary quiet of open northern water. Below the hull, the Baltic was doing what the Baltic does at that depth in that season, which is to say, very little that could be seen. The water column at 85 meters in the northern Baltic is cold throughout the year, cold enough that unprotected skin registers it within seconds as something demanding to be removed from. In summer, the upper layers warm slightly, but warmth does not reach that far down in any meaningful way. What the divers would be descending into was close to the same cold darkness the seafloor beneath them had held for years, for decades, for longer than any living person had had cause to think about it. Peter Lindbergh was on deck that morning. Dennis Osberg was on deck. The team included outside researchers and journalists who had come to observe the expedition and document whatever the dive produced. And among the equipment being readied was an underwater remotely operated camera that would descend alongside the divers, recording what the dive lights reached and what the murky Baltic water allowed to be seen. The operation had taken months to organize. The return to the site had been the point of it. What the team hoped to bring back to the surface was something more concrete than a sonar image, a first-hand account from divers who had touched the thing, samples from its surface, footage from a camera that had been there. The descent began in the particular way all deep dives begin, which is one at a time and slowly. The divers entered the water off the side of the vessel and began to go down. The Baltic at 85 meters receives almost no light from the surface. Even in summer, at that depth, the water is effectively dark, not the absolute darkness of the deep ocean, but a low and featureless gray that the dive lights cut into in a narrow cone and that closes again beyond the reach of that cone. The divers' equipment lights were the only source of illumination below roughly 20 meters. Below that, the water column above them closed off the sky entirely, and what they moved through was cold, dark, and particulate dense, the suspended matter of the Baltic, sediment, biological material, the slow drift of things that do not settle, reducing visibility to a matter of meters in any direction. The seafloor, at 85 meters in the northern Baltic, is flat sediment over the underlying geology of a region reshaped by glaciation over thousands of years. The divers descended toward it through water that gave them very little to look at and a great deal to feel, the pressure increasing steadily as they went down, the cold stable and total, the silence of deep water, broken only by the sound of their own equipment and the slow regulated rhythm of their breathing. The line between the water column and the seafloor does not announce itself dramatically at this depth. The sediment comes up slowly as the diver approaches, a slightly denser darkness below, then a surface resolving from the general murk, then ground. What the divers reported finding when they reached the site was a dark, rough surface. The accounts given by different members of the dive team described the material as stone-like, as rock, or as something that had the texture and apparent density of rock, dark in color under the dive lights, and irregular in the way that natural stone formations are irregular. Some divers reported sections that appeared flat relative to the surrounding surface. Others described what they characterized as angular features, edges or corners that interrupted the rounded or irregular forms of the surrounding material in a way that struck them as unusual. Ocean X team presented these descriptions in their subsequent public accounts as potentially consistent with artificial construction, with the implication that what the divers had found might have been shaped by something other than natural geological process. Marine geologists who reviewed these accounts offered a different characterization. The Baltic seafloor in the region where the anomaly sits contains a well-documented variety of rock types and formations, basalt, granite, and other materials transported and deposited by the Vixelian glaciation that shaped the entire Baltic basin in the period before the sea, as it now exists, came into being. Angular features and flat sections are consistent with how basaltic rock fractures and how glacially transported boulders sit on seafloor sediment. What the divers described as unusual could, geologists noted, be matched without difficulty to known natural rock morphologies found throughout the region. The darkness of the material, its rough texture, its apparent density, none of these characteristics placed it outside the range of what the Baltic seafloor ordinarily holds. The low visibility of the dive complicated everything. The Baltic at that depth in early summer is not a place where precise visual inspection is easy to conduct, or where the impression formed by a diver in cold water with a narrow cone of dive light can be held as a reliable document of what the surface actually looked like. The divers were working in conditions that reduced the range of their vision to a few meters at most, that made long-range assessment of the formation's overall shape impossible from any single position, and that made the identification of material type from surface appearance alone a genuinely uncertain exercise, even for experienced divers. The accounts they gave were honest accounts of what they had seen and felt and perceived. The conditions in which those perceptions were formed were genuinely difficult ones. The remotely operated camera descended to record the site alongside the human divers. Its footage captured the same cold, murky, poorly lit environment that defined the human dive. A limited field of illumination, dark sediment, and dark stone surfaces at the edges of the frame. The particulate matter of the Baltic drifting through the light cone like a slow, fine snow that the camera could not see through and could not exclude from its field of view. The footage was reviewed by the team and released publicly alongside the dive accounts. What it showed was consistent with what the divers described: dark material, irregular surfaces, something that could be examined at close range but not seen as a whole from any single vantage point. The conditions the camera operated in were the same conditions that made the sonar image, produced from above the seafloor rather than upon it, the clearest single representation of the formation's overall shape that the team had been able to produce. Among the reports that emerged from the 2012 expedition and attracted significant public attention was the claim that electronic equipment had failed in ways that the team described as unexplained. Satellite phones were reported to have ceased functioning when operated directly above the Anomaly site. Cameras were reported to have malfunctioned. These accounts were presented by OceanX team and by the media outlets covering the expedition as potentially significant, as a pattern of electronic disruption associated specifically with proximity to the formation. The claim entered the public record of the Baltic Sea anomaly as one of its most frequently cited elements, reproduced in articles and documentaries in the years that followed, as a detail suggesting that the formation had properties not found in ordinary geology. Engineers and skeptics who addressed the equipment failure claims publicly offered a range of documented alternative explanations, and electronic equipment in marine environments is subject to a suite of degradation factors that are well established and that can produce failures under conditions having nothing to do with any unusual property of the seafloor below. Saltwater exposure is corrosive in ways that accumulate and can produce intermittent failures of unpredictable timing. Cold temperatures reduce battery performance substantially and can cause sudden device shutdowns in equipment that was functioning normally in warmer conditions. The electromagnetic environment around a working survey vessel includes a range of sources, communication systems, engine electronics, navigation equipment that can interfere with sensitive devices. None of the equipment failures reported during the 2012 expedition were documented by independent technical assessors in circumstances that established a causal connection to the anomaly site. They occurred in an environment that provided multiple ordinary explanations for intermittent device failure. The pattern that seemed significant when described against the background of the anomaly looked considerably less unusual when placed alongside the documented technical challenges of operating sensitive electronics in Baltic deepwater conditions. The rock samples recovered during the 2012 expedition were among the most concrete products of the dive. Physical material brought up from 85 meters of Baltic water and examined on the surface the kind of evidence that can in principle be analyzed by instruments and methods that are not subject to the interpretive ambiguity of a diver's impression in dark, cold water. Ocean X team described the samples as showing signs of high heat exposure. Team members and associated commentators described the recovered fragments as having sooty or carbon-like characteristics on their surfaces. And this description was interpreted in public Ocean X team statements as potentially indicating that the formation or material had been subjected to extreme heat at some point in its history, a characteristic not naturally produced by geological deposition in the Baltic. Geologists who examined or reviewed descriptions of the recovered samples offered assessments that placed the material firmly within the range of rock types found throughout the Baltic region. The fragments were identified as consistent with volcanic basalt and granitic rock. Both rock types are naturally present in the Baltic Basin in quantities that reflect the region's geological history. Basaltic rock produced by ancient volcanic activity, long predating any human presence in the region. Granitic material transported by glaciation from the Scandinavian continental geology into the Baltic Basin during the Weichselian glaciation and deposited there when the ice retreated. The surface characteristics described as sooty or carbon-like were assessed as consistent with the natural weathering and mineral staining that occurs in seafloor rock over long periods of submersion. No independent geologist reviewing the samples or their documented characteristics found it necessary to invoke extraordinary heat exposure or any process outside normal Baltic geology to account for what the material showed. The public accounts that emerged from the 2012 expedition were not uniform. This was one of the more complicated dimensions of the aftermath. Among the people who dived to the site, and among the researchers and observers who were present on the vessel during the expedition, the descriptions of what had been found did not converge on a single interpretation. Some accounts from individuals associated with the dive described the formation as almost certainly geological, as a natural feature of the Baltic seafloor, consistent with what marine geology predicted would be found in that region. Other accounts, including those given by some Ocean X team members in interviews and press materials, continued to use language that implied something more extraordinary, formations that were difficult to explain naturally, characteristics that the speakers described as requiring more investigation than the geological explanation had so far provided. Journalists and researchers who covered the expedition after the fact noted these discrepancies. Two people who had dived to the same site within the same expedition could give accounts that, placed side by side, seemed to describe different degrees of unusualness. One diver's stone-like surface with unremarkable angular features was another observer's structure with characteristics difficult to account for. Geologically, the physical conditions of the dive, the darkness, the cold, the limited visibility, the brevity of the working window imposed by decompression requirements, provided a genuine and documented explanation for why different observers might form different impressions of the same surface. People perceive differently under stress and discomfort. Attention narrows in cold water. The dive light illuminates a small area at a time, and what that area contains shapes the diver's impression of the whole in ways that subsequent reflection may not fully correct. The divergence in the accounts was described by skeptics as evidence of the anomaly's ultimate unremarkability. If the formation were clearly extraordinary, the accounts would agree, and by the team's more committed advocates, as evidence that the truth of what was down there had not yet been fully established. What persisted through all of this, through the diverging accounts, the equipment failure claims, the geological assessments of the rock samples, the footage from the remotely operated camera, was the basic physical reality that a dive team had gone to the site and come back with something. That something was not a clear answer. The divers had seen a dark, rough stone-like surface in conditions that made thorough visual inspection genuinely difficult. They had described features they found unusual, and those features had been explained in natural terms by geologists who reviewed the descriptions. They had brought up rock fragments that analysis placed within the ordinary geological range of the Baltic. They had reported equipment failures that technical assessors attributed to the known challenges of the marine environment. None of this added up to a definitive conclusion in either direction. The formation at 85 meters depth in the northern Baltic was neither confirmed as extraordinary nor definitively ruled out by the 2012 expedition. It remained what it had been since the sonar image was first released, an object on the seafloor whose interpretation was contested, whose physical characteristics were documented under difficult conditions, and whose status in the public record was determined as much by the circumstances of its discovery and presentation as by anything the divers found when they reached it. Below the water, while all of this was being processed and discussed on the surface, the formation sat in the cold, dark sediment of the Baltic seafloor, exactly as it had sat before the Ocean X Team vessel arrived above it. The rough, dark, stone-like surface the divers had described received no light and held no temperature above the ambient cold of the Baltic deep. The linear feature extending from the main form across the seafloor continued in the same direction it had always continued, ending where it had always ended. The sediment around it, undisturbed by anything except the current that moved through that depth, in the way the Baltic current has always moved, slowly and without any particular attention to what it passes over. The divers had touched the surface. The camera had recorded it. The samples had been carried up through 85 meters of cold water and examined in daylight, and the result of all of this was a collection of accounts that did not entirely agree with each other. A set of rock fragments that geologists identified as ordinary, footage from a remotely operated camera that showed cold, murky water and dark stone in a narrow cone of light, and a set of equipment failure reports that could be explained by the conditions of the marine environment without reference to anything beneath it. The satellite phone sat dead on the deck of the vessel in the gray light of the Baltic summer, the water below it flat and cold, the divers somewhere in the process of their ascent through 85 meters of dark water, each of them carrying their own impression of what they had found, an impression formed in cold and dark and limited visibility and the physical difficulty of working at that depth, an impression that would be described and redescribed in the months and years that followed, in ways that continued to diverge, each account true to the experience of the person who gave it, and none of them quite sufficient to settle what the formation actually was. The recovered rock fragments sat on the deck in the daylight once the divers had surfaced. It was dark and heavy in the hand, the way that dense stone is heavy, the particular weight of material that has sat in cold water for a very long time. Its surface showed the characteristics that had been described as unusual, the dark coloration, the texture, whatever it was that the team had characterized as signs of high heat. In the Baltic summer light, on the deck of a vessel that had come a long way to find this, the fragment looked like what geologists would subsequently say it was, a piece of volcanic rock consistent with the geological history of the Baltic basin, a piece of the seafloor that the seafloor had been holding long before anyone thought to look for it. Team members examined it. They turned it over. They looked at the surface in the direct light, which was the clearest view of it that anyone had had, clearer than the dive lights had allowed at depth in murky water. What they found in that examination was not what they had expected. Not because the fragment contradicted the impressions formed at depth. Those impressions had been formed in conditions that made precision difficult, but because the fragment, held in daylight on the surface, was not as obviously extraordinary as the account of the formation that produced it might have suggested. It was a piece of dark rock. It was heavy and rough, and it had come from a formation sitting 85 meters below the surface of the northern Baltic Sea. It had made the journey from that depth to the deck of the vessel, and it had arrived as what geologists would say it was, a piece of the seafloor. The thing it came from was still down there. The formation, whatever it was, the raised circular feature with its outer rim, its domed center, the long linear marking extending away from it across the flat sediment of the Baltic seafloor, was still sitting at 85 meters depth in the cold dark of the northern Baltic, unmoved by the expedition that had come to examine it, unchanged by the hands that had touched its surface, or the camera that had recorded what could be recorded of it in those conditions. The question of what it was had not been answered by the dive, though the dive had added to the record of documented observation that would inform every subsequent discussion of it. The accounts the divers gave in the weeks and months after the expedition added their own layers to the accumulating record. In interviews and press materials, in the statements that Ocean X Team made to the journalists who had come along to document the return to the site, in the conversations between researchers who had been present and those who reviewed the material afterward, the formation was described in terms that reflected the genuine complexity of what the dive had produced. Some descriptions settled toward the geological, others remained uncertain in a way that was not performance, a genuine inability on the part of people who had been there to feel fully satisfied by either the extraordinary or the ordinary account. The dive had been real. The descent through cold, dark water had been real. The rough, dark surface at 85 meters had been real in the way that things touched in difficult conditions are real. The samples were real, the footage was real, and the interpretation of all of it remained as it had been before the divers went down. Genuinely contested, not because the evidence was fraudulent, or because the satellite phone, or another one, worked again once the vessel was some distance from the site, or it did not work for reasons connected to the marine environment and its demands on electronic equipment. The rock fragment was packed and stored, the footage was archived, the accounts were recorded in notes and interviews, and the particular memory of people who had been cold and working at depth and who had come back up through 85 meters of dark water with their own impression of what they had found there. In the months that followed, the discrepancies between accounts emerged gradually, in the way that discrepancies in honest first-hand observation always emerge, not as revelations or contradictions, but as the slow accumulation of slightly different descriptions of the same experience, each one true to the person who gave it, none of them definitively superseding the others. The dark, rough surface was described and redescribed. The angular features were described and assessed. The equipment failures were reported and explained. The samples were analyzed and the analysis was reported. And the formation remained at 85 meters depth in the northern Baltic, neither confirmed nor explained. The cold water above it and the cold sediment below it, and the particular darkness of the Baltic deep surrounding it in all directions, patient in the way that things at the bottom of cold northern seas are patient. The rock sample sat on the examination table in the daylight, dark, dense, ordinary in the hand, its surface bearing whatever characteristics had led to the team's assessment of high heat exposure, and bearing also the assessment of geologists who had found in those same characteristics the evidence of volcanic origin and long seafloor submersion rather than of anything more unusual. The thing it came from had not moved. It had been there before the divers arrived, and it was still there after they left. What it was had not changed during the expedition, even if the understanding of it had shifted slightly in the direction of the geological slightly toward the claim that what the sonar had shown was something the Baltic seafloor holds in the ordinary course of its geological history, something shaped by ice and time rather than by anything requiring a different explanation. The vessel moved back toward port. The water was still flat and cold and gray. The equipment on deck was sorted and stored. The accounts began their long life in interview transcripts and press materials and the documented record of an expedition that had gone to the site of a sonar anomaly and come back with rock samples, footage in murky water, diverging impressions, and nothing that settled the question definitively in any direction. The formation was still there at 85 meters depth, as it had been before anyone thought to look for it, and as it would remain in the years that followed, cold and dark, and neither confirmed nor explained. The sample that came from it, sitting in daylight on the deck of the vessel that had carried it up from the deep, dark ordinary in the hand, its origin still sitting below the flat gray surface of the northern Baltic Sea. The Baltic seafloor in the region north of Gotland is not a flat and featureless plain. It is a terrain that holds pressed into its sediment and written across its stone the record of one of the largest geological events in the history of northern Europe, a glaciation that ended approximately 10,000 to 12,000 years ago, when the Vixillian ice sheet retreated northward and left behind a landscape remade in its entirety. The seafloor there carries ridges of deposited material. It carries isolated boulders dropped from the underbelly of the retreating ice. It carries long linear marks drawn into the sediment by ice dragging across the bottom as it moved. It carries mounds, depressions, and formations shaped not by water, but by the weight and motion of ice that is now long gone, leaving only the shapes it pressed into the earth beneath the sea. That geological inheritance is documented. It has been mapped, sampled, cored, and studied by Baltic marine researchers working across several decades, and the picture it produces is one of considerable complexity, a seafloor shaped by forces operating over millennia, leaving behind features that range from the subtle to the pronounced, from the smooth to the angular, from the easily recognizable to the genuinely difficult to classify without detailed field analysis. The Baltic in the region of the northern basin, where the anomaly was located, sits squarely within this documented landscape of glacial deposition. It always has. The ice that shaped it retreated roughly 10,000 years ago, and the features it left are still there, sitting beneath cold water, accumulated in sediment, holding still in the particular quiet of the deep Baltic floor. Swedish geologists and marine researchers who reviewed the publicly released sonar image of the Baltic Sea anomaly placed it within this documented context. Their assessments, offered through public commentary and institutional statements in the period following the sonar image's release, attributed the object to natural geological processes consistent with the known history of the region. The sonar image, they noted, was not sufficiently unusual from a geological standpoint to require anything beyond the explanatory frameworks already in use for the Baltic seafloor. The feature appeared to be circular and raised. Features that are circular and raised occur naturally throughout the Baltic region. The correspondence between the reported sonar characteristics and the documented range of natural formations in that seafloor zone was, in the assessment of the researchers who examined it, close enough to settle the question at the level of working geological understanding. even without a full physical investigation of the site. That assessment was not dismissive. It was grounded in a detailed and long-standing body of research into Baltic seafloor formation that stretches across institutional archives, published survey data, and decades of scientific work specific to this region. The Baltic is, in geological terms, a well-studied sea. Its seafloor has been surveyed more extensively than many comparable bodies of water, partly because of its importance as a shipping and military waterway, partly because of its environmental sensitivity, and partly because the glacial legacy it holds is itself a subject of serious scientific interest, separate from any question the anomaly raised. The ice that shaped it left a record that researchers have been reading for a long time. Researchers associated with Stockholm University's geology and marine science departments were among the Swedish academics who offered public commentary contextualizing the anomaly within this broader scientific understanding. The institution's documented research history in Baltic Sea geology and paleoclimatology gave those assessments a grounding in accumulated primary data rather than in general principle. These were researchers familiar with the specific regional geology, with the documented range of formations the Weichselian glaciation produced in this precise area, and with the capabilities and limitations of the sonar technology used to produce the anomaly image. Their contextualization placed the object within a landscape they had spent careers studying, not a foreign feature in an unknown place, but a formation sitting in a region whose geological character is one of the better documented in Baltic marine science. The Weichselian glaciation, to hold it for a moment in something like its actual scale, was not a local event. It was the last major glacial cycle of the Pleistocene epoch, and at its maximum extent, the ice sheet covering northern Europe was between 2 and 3 kilometers thick, in places moving southward under its own accumulated weight, and carrying with it enormous quantities of rock, sediment, and debris scraped from the land and seafloor beneath it. When it retreated, beginning roughly 15,000 years ago and completing its withdrawal from the Baltic region by approximately 10,000 years ago, it deposited what it had been carrying across the landscape and the seafloor of the area we now call the northern Baltic. Drop stones, ground moraines, end moraines, scour marks, mounded formations built from accumulated glacial material, irregular shapes pressed into the sediment by the weight and drag of ice moving at geological pace across the bottom. A glacial drop stone is a specific and documented formation. It is a large boulder, sometimes very large, that was carried embedded in the ice sheet and deposited on the seafloor or landscape when the ice that held it melted. The Baltic seafloor holds thousands of them, sitting in isolation on flat sediment, their presence explained entirely by the transport mechanisms of the glacier that carried them and deposited them when it retreated. Some are rounded, some are angular. Some have been further shaped by the movement of Baltic water and the pressure of accumulated sediment over the 10,000 years since their deposition. They come in a wide range of sizes. They sit individually and in clusters across the seafloor of the region in the same way that isolated boulders sit on land in areas of known glacial deposition as the most visible and obvious evidence of what happened there. The sonar image of the anomaly showed a raised circular form approximately 60 meters across, sitting on a flat seafloor plain. A glacial erratic of that scale, a large boulder or consolidated mass of glacially deposited rock, would appear in side-scan sonar imagery as a raised feature, generating a shadow return, its shape in the acoustic image influenced by its surface geometry, its composition, and the angle of the sonar pulse. The circular appearance of such a feature in sonar return is not unusual. Boulder-shaped formations with roughly circular or dome-like upper profiles produce circular sonar shadows. The resolution limitations of side-scan sonar in Baltic sediment conditions, where particulate suspension and thermal layering affect acoustic return, can produce an impression of regularity and defined edges that may not fully correspond to the actual surface geometry of the feature being imaged. Geologists familiar with Baltic sonar survey work noted this specifically in their assessments that the apparent geometric precision of the anomaly in the sonar image was within the range of what naturally occurring formations produce under these survey conditions. That observation is not a dismissal of the sonar data. It is a specific technical point about the relationship between acoustic imaging conditions and the visual impression produced by the resulting image. Side-scan sonar is a well-understood technology with documented limitations, and those limitations are particularly relevant in the Baltic, where conditions at depth introduce factors that affect the acoustic return in ways that are themselves well studied. The sonar image of the anomaly is a real image of a real feature. What it shows and what it does not show is constrained by the physics of the imaging process and the environmental conditions in which it was conducted. Naturally occurring disc-shaped and circular geological features are documented on ocean floors across the world, produced by a range of distinct processes, each well understood within the relevant scientific literature. Pockmarks are one such formation, circular depressions created by the venting of gas or fluid from subsea floor layers, which can reach diameters of tens to hundreds of meters and appear in sonar imagery as defined circular features. Subsurface collapse, where the dissolution or compaction of material beneath the seafloor creates a void whose sealing eventually fails, can produce circular or oval depressions at the surface. And sedimentary concretions, hardened mineral masses that form around a nucleus in sedimentary environments through the gradual accumulation of dissolved minerals, precipitating out of the surrounding sediment, can grow over geological time into rounded, dome-like forms with smooth or irregular upper surfaces, sometimes reaching sizes comparable to large boulders and sometimes larger. A sedimentary concretion brought out of the seafloor and examined in a research setting would present as a heavy, dense, roughly rounded, or dome-like mass with a composition distinct from the surrounding sediment, harder, more mineralized, with a surface texture determined by the specific minerals involved in its formation. In sonar imagery, a large concretion sitting on a flat sediment plain would generate a return consistent with a raised, roughly circular or dome-like feature with defined edges and a shadow extending away from it in the direction of the sonar pulse. The Baltic seafloor contains sedimentary environments in which concretion formation is geologically plausible. The reported characteristics of the anomaly, raised form, roughly circular profile, defined outer edge, dome-like central section, are consistent with what a large concretion would produce in a side-scan sonar survey at Baltic conditions. None of these geological frameworks require unusual circumstances or conditions not already documented in the Baltic region. The formations they describe, drop stones, glacial moraines, scour features, concretions, pockmarks, are all present in the documented record of Baltic seafloor geology. They have been surveyed, sampled, and studied. They are part of the known landscape of the Baltic Deep. The anomaly, sitting at approximately 85 to 90 meters depth in the northern Baltic Basin, sits within a region where these formations are expected, where their occurrence is documented, and where the geological processes that created them are well established. The 300-meter linear feature extending from the main formation was also specifically addressed in the geological assessments. That feature, described by Ocean X Team as a trail or skid mark running across the seafloor away from the circular form, is consistent with glacial scour marks of the kind documented extensively throughout the Baltic seafloor. A glacial scour mark is created when a large mass of ice or a boulder embedded in the underside of a moving glacier drags across the seafloor during glacial advance or retreat. The result is a long, narrow linear groove or depression running across the sediment, often straight or gently curving, extending for hundreds of meters or more, depending on the size of the object, creating it and the distance it traveled. These marks are common in the Baltic. They have been mapped in sonar surveys across the basin. They survive in the sediment record as some of the clearest visible evidence of glacial movement across the Baltic floor. A glacial scour mark, 300 meters long, is not unusual in the Baltic context. Scar marks of several times that length have been documented in the region. The morphology described for the anomaly's linear feature, a narrow marking extending from a larger circular form, is consistent with the documented pattern of glacial scar associated with large boulders or ice masses that came to rest after dragging across the floor, leaving a linear mark ending at the point of final deposition. No reviewing geologist who commented on the anomaly's reported features described the 300-meter linear extension as dimensionally or morphologically inconsistent with known glacial scour processes. It was, in their assessments, one of the features most readily accounted for by the existing geological record of the region. The unhurried reading of these geological explanations is worth holding for a moment, not because the explanations are simple, but because they are genuinely interesting on their own terms. The Baltic seafloor at the depth of the anomaly is a place shaped by events that happened 10,000 years ago, carrying the record of an ice sheet that covered northern Europe to a depth of kilometers, moving through the landscape with a weight and force that remade everything it touched. That the marks of that movement are still visible in the sediment at 85 meters of depth, still readable in sonar surveys, still identifiable in their morphology after 10 millennia under cold Baltic water, is itself a detail worth sitting with quietly. The ice that made those marks is entirely gone. The water that replaced it has been sitting over those scour lines for roughly 10,000 years. The boulders dropped into that water by the retreating glacier have been sitting in the cold dark at the bottom ever since, not moving, held in their positions by their own weight and by the accumulated sediment pressing around their lower surfaces. The formations shaped by that process, the ridges, the moraines, the circular features, the linear marks, have been accumulating their thin covering of Baltic sediment since the ice left, resting in the particular stillness of things that were placed somewhere a very long time ago and have not been disturbed. Stockholm University's relationship to Baltic marine science is deep and long. The institution's marine geology and paleoclimatology research programs have produced decades of published work on Baltic seafloor formation, sediment coring studies, and glacial legacy mapping that together constitute a substantial portion of what is known about the geological character of the Baltic Deep. The archives that hold that research, sediment cores taken from the Baltic Basin, maps of glacial deposition patterns, survey data from sonar and acoustic imaging programs, represent an accumulated record of the region's geological history that extends well beyond any single formation or anomalous feature. The anomaly, placed within that record by the researchers who reviewed the sonar image, is one data point among many, considered within a body of reference that extends broadly across the Baltic floor. That context does not make the anomaly smaller. It makes it legible in a way that the sonar image alone, reproduced without geological context across news platforms and documentary programs, could not be. A shape in isolation is a mystery. A shape placed within a documented landscape of similar shapes, produced by well understood processes operating over geological time, is a formation interesting in its own right, worth examining carefully, but no longer requiring an explanation outside the range of what is already known. The distinction between those two framings is one that geological science and popular mystery culture have handled very differently with respect to the Baltic anomaly. Scientific assessment moved relatively quickly toward a geological explanation and found the available evidence consistent with that explanation. Popular coverage found in the unverified sonar image the particular quality of the unexplained that open questions in deep water tend to carry, and that quality, once established, is not easily displaced by a geological assessment offered through institutional channels in technical language. There is something worth noting in that gap, held without judgment. The geological explanations for the Baltic anomaly are not dramatic. They do not require the seafloor to hold something extraordinary. They require it to hold what it demonstrably does hold, the deposited record of a glacial cycle that ended 10,000 years ago, expressed in a landscape of ridges and boulders and scour marks and mounded formations that extend across the Baltic floor in every direction from the anomaly's position. That is, in geological terms, a rich and genuinely interesting record. It is simply not the kind of interesting that travels easily across news platforms. The sediment cores that Baltic marine researchers have taken from this region over the years carry in their layered structure a detailed record of the Baltic's history, the transition from glacial meltwater lake to brackish sea to the present connected basin, the changes in sedimentation rate and composition across millennia, the biological record preserved in the chemistry of deposited material. Each core is a column of time pressed into a cylinder of sediment, readable by researchers trained in the specific language of its layers. The anomaly sits in a seafloor that produced those cores, in a region that has been studied with those methods, in a basin whose history is documented in institutional archives in a way that few comparable bodies of water can match. The glacial scour marks visible in sonar surveys of the Baltic floor are among the most direct records of the ice sheet's final movement across the basin. They were made by something moving, ice moving northward as it retreated, dragging whatever was embedded in its lower surface across the seafloor as it went. When the ice was gone, the marks remained. They have been sitting there ever since, quiet and precise, recording in the sediment the direction and character of the movement that made them. Some are single lines, some are clusters of parallel marks made by multiple objects moving in the same direction at the same time. Some end at a boulder, the boulder itself sitting at the terminal point of the groove it created, the physical record of its own passage preserved in the sediment behind it. The 300-meter linear feature associated with the Baltic anomaly, read within this documented context, fits comfortably within the range of what glacial scour produces in Baltic conditions. The length is consistent with documented scour marks in the region. The morphology described, a narrow marking ending at a larger circular form, matches the pattern of a boulder that dragged across the floor and came to rest. The direction of the feature and its relationship to the main formation have not been reported as inconsistent with the known orientation of glacial movement in that part of the northern Baltic basin. The feature, in the assessments of the geologists who reviewed it, required no explanation beyond the well-documented glacial history of the region it sits within. There is a particular quality to the geological time of the Baltic floor that is worth resting in for a moment before moving further. 10,000 years is in human terms an enormous span. It is longer than all of recorded human history. It is long enough that the civilizations that existed when the Baltic ice sheet began its final retreat are not remembered by name, not preserved in written record, not accessible through anything except the material evidence they left in the ground. It is the distance between now and a world that was, in the most basic physical sense, a different landscape, where the northern Baltic basin held not open water, but a glacial lake, and before that, a landscape under ice, and where the geography of the coastline, and the depth of the water, and the temperature of the air above it were all different from what they are today. The Baltic seafloor remembers that time in the only way a seafloor can. It holds it in its formations, in its sediment layers, in the boulders deposited on it, and the marks drawn across it by the ice. The anomaly, whatever its precise geological identity, sits within that record. It is part of the same landscape of deposited and shaped material that covers the Baltic floor across this entire region, material placed there by the same events, held under the same water, accumulating the same slow covering of fine Baltic sediment over the same 10,000 years. A mounded feature of the kind consistent with glacial deposition or with concretion formation in a sedimentary environment does not announce itself. It sits on the seafloor in the cold, in the dark, in the near silence of 85 meters of Baltic water, holding its shape with the patience of something that has been there long enough, that patience is no longer a concept it requires. The Baltic water moves above it in the slow current patterns of the deep basin. The sediment around its base accumulates at the rate that Baltic sediment accumulates, gradually, incrementally, in layers too thin to measure by year or by decade. Time passes in the way that time passes at the bottom of a cold northern sea. Marine geologists who have spent careers working in the Baltic understand the seafloor they study in a way that the sonar image reproduced across news platforms could not convey. They understand it as a place with a specific geological history, a documented depositional record, and a known range of formations produced by processes that have been studied in careful detail. When they examined the sonar image of the anomaly and placed it within that understanding, the assessment they arrived at was consistent across the reviewing researchers who commented publicly: a natural geological feature, likely of glacial or sedimentary origin, sitting in a region where features of that kind are expected and documented. That consensus did not resolve the public conversation about the anomaly. It offered an explanation grounded in documented science, accessible to anyone who sought it out. Whether it was sought out, and in what proportion relative to the alternative framings circulating in the same information environment, is a separate question, one about how explanations travel through media ecosystems and public attention, rather than about the geological character of the Baltic seafloor. The Baltic floor, where the anomaly sits, is in documented geological terms a rich place. It holds the record of the last ice age in its formations and its sediment. It holds thousands of years of accumulated Baltic history in its layers, the biological and chemical record of the basin's changes, preserved in the quiet chemistry of deposited material at depth. It holds isolated boulders, placed there 10,000 years ago by ice that no longer exists, sitting in the same positions they were deposited in, unchanged except for what time and water and accumulated sediment have done to their surfaces. It holds the marks made by that same ice as it moved across the bottom during its final retreat, long, quiet lines in the sediment, still readable in sonar surveys, the clearest record available of how the glaciation ended in this particular part of the northern Baltic Basin. The geological story of the Baltic floor is, in its own terms, one that rewards sustained attention. It is the story of a landscape remade by an event on a scale that exceeds ordinary geological imagination, an ice sheet covering northern Europe to a depth of kilometers, moving, then retreating, leaving behind a rearranged and deposited landscape that became over 10,000 years the seafloor of the modern Baltic Sea. Every mound, every ridge, every scour mark, every isolated boulder visible in a Baltic sonar survey is part of that story. The anomaly placed within it is part of it too. The scour marks on the Baltic floor run in the direction the ice moved. They record in the sediment the final motion of a glacier that covered this part of the world for thousands of years before it was gone. The marks are long, they are quiet. They are still there, under the cold Baltic water, running across the seafloor in the direction of the ice's last movement, holding their shape in the sediment, with the same patience they have held it since the water covered them, and the current began moving slowly above them in the dark. Some of those marks end at a boulder. The boulder sits at the terminal point of its own passage, the groove behind it, its only monument, the sediment around its base, 10,000 years deeper than it was when the ice left it there. The Baltic water moves above it. The light does not reach it. It holds its position in the sediment with the particular stillness of something that was placed in the earth a very long time ago and has not been disturbed by anything since, not by the Baltic's shifting history of salinity and current, not by the accumulated sediment of 10 millennia, not by the cold and the dark and the slow movement of water above it, and not by whatever questions the sea still holds, patient and unannounced in the quiet of the deep northern basin. As of the mid-2020, no official scientific body has issued a formal conclusion specifically addressing the Baltic Sea anomaly. That fact is worth holding for a moment, not because it suggests concealment, not because it implies that the question remains genuinely open in any scientific sense, but because it describes something precise and procedural about how institutions allocate the resource of formal investigation. The Baltic seafloor formation did not, in the assessment of the relevant scientific community, meet the threshold that would direct sustained institutional inquiry toward it. Swedish marine geologists reviewed the sonar image. They offered assessments. They described what they saw in the acoustic return as consistent with the glacially shaped landscape of the northern Baltic, a region whose seafloor is dense with a deposited legacy of ice. And then they returned to their other work, because the question, from their position, did not require anything more. What remained after that, the open institutional space, the absence of a formal closing statement, the case file that was never officially opened, and therefore never officially closed, became something that the cultural life of the anomaly moved into and made its home. Peter Lindbergh has continued to give interviews. That is a simple fact, and it carries no accusation. He found something on the seafloor of the northern Baltic Sea that he could not immediately account for, and he has continued to say so through successive news cycles and documentary productions and online conversations that span more than a decade of the internet's evolving interest in unexplained things. Dennis Osberg has remained similarly present, and Ocean X Team, as a continuing enterprise, has kept the story alive in the particular way that only the people who found a thing can sustain, by being there to answer questions, to describe what the sonar showed, to describe what the divers saw at depth, to hold the position that the object warrants ongoing attention. Their presence in the record is active. The story persists in part because they have remained willing to tell it. The documentary world noticed early. Productions focused on unexplained ocean phenomena, on the mysteries of the deep, on cases that sit outside the boundary of established scientific explanation. These are a durable and popular genre, and the Baltic Sea anomaly arrived already formatted for inclusion. A circular object on the seafloor, a team of divers with conflicting impressions, rock samples that open questions without answering them, equipment that failed in the cold water above the site. The production requirements of an episode or a segment were already met by the record as it stood, and the anomaly appeared on screen in multiple productions across the years following 2012. What these programs typically gave significant airtime to was the range of extraordinary interpretations, the extraterrestrial hypothesis, the possibility of an ancient constructed object, the idea that the Baltic seafloor held something that geological science could not account for. The assessments offered by Swedish marine researchers received less time, not because the programs were actively misleading, but because the genre operates on a logic where the most open question makes the most compelling hour. A disc-shaped rock formation left by glacial processes over 10,000 years ago is a true and interesting story. It is a harder story to sustain across 45 minutes of television than the possibility of something else. The streaming era extended the anomaly's reach further and into new formats. Short-form video platforms hosted hundreds of independently produced investigations, some detailed and careful, many not, all adding their own layer of attention to the acoustic image that Lindbergh and Osberg released in 2011. A sonar image is well suited to that format. It is stark. It is visually distinctive. It reproduces clearly in a thumbnail, and it does not require the viewer to commit to much before it raises its question. The circular form sitting on the flat Baltic seafloor, the trail extending behind it for 300 meters, the raised rim and the central dome. These features are legible in still image, and they circulated accordingly across platforms and languages, accumulating views in the particular quiet way that images accumulate views, when the question they raise has no settled answer attached to them. The books came next, or arrived alongside, in the way that popular mystery publishing and online culture have always run in parallel. The Baltic Sea anomaly became a standard inclusion in collections of the world's greatest ocean mysteries, appearing in chapters between entries on the Yonaguni Monument off the coast of Japan and the Bimini Road Formation in the waters of the Bahamas, a genre company that says something about the kind of cultural object the anomaly had become. Each of these formations has its documented geological explanations and its persistent alternative theories, and each of them appears in the same publications because they share a structural characteristic. They are real physical things in real bodies of water. They have been seen and measured and argued over, and the question of what they are has not been resolved in a way that satisfies everyone who has looked at them. The Baltic Sea anomaly fits that template precisely. It is not a rumor. It is not a digitally produced image. It is a documented acoustic return from a specific location on the northern Baltic seafloor, and it has sat in that company on printed pages and in website lists since the early 2010, without the passage of time diminishing its place there. The Baltic Sea itself prepared the ground for this reception. That is not a small or incidental thing. The Baltic carries more than 1,000 years of documented maritime history as one of the major trade and military corridors of Northern Europe, a body of water through which Viking traders moved goods from the east, through which the Hanseatic League conducted the commerce that shaped medieval Northern Europe, through which World War I and World War II Both left their material traces in the form of warships and cargo vessels sitting on the seafloor at depths that preserve them in the cold, low salinity water. The Baltic holds thousands of known shipwrecks and an unknown number of undiscovered ones. It is a body of water that people who work on it and live near it and study it understand to contain things, real things, documented things, objects of genuine historical weight sitting in the deep water below the gray surface. Peter Lindbergh was looking for some of those documented things when his sonar returned the image that became the Anomaly. The expedition was a commercial salvage operation targeting historically attested wrecks. The Anomaly was not what he was looking for, and it did not fit the category of what he expected to find. And in a body of water that is known to contain surprises on its seafloor, that unexpectedness carried a particular kind of weight. The community that formed around the Anomaly online drew on the wider Baltic maritime imagination, the sense of the sea as a place that holds things without being reducible to it. What online mystery communities do with cases like this one is something somewhat different from what documentary producers do or what popular mystery books do. The communities dwell in the case at a finer resolution, returning to the sonar image repeatedly, debating the specific features, the dimensions, the trail, the surface descriptions, the divers provided, the rock samples, the equipment failures, the inconsistencies between accounts. The conversation is ongoing in the specific way that online conversation is ongoing. It does not conclude. It does not reach a consensus and disband. It continues to accumulate perspectives and counter arguments and new framings of the same documented material. The image of the circular form on the Baltic seafloor at the center of it, unchanged and unchanging across years of accumulated discussion. That image has a specific quality that suits this kind of persistence. A side-scan sonar rendering is not a photograph. It is an acoustic representation, sound translated into shape, the seafloor described in the reflected return of pulses sent down through cold water at depth. What that process produces is a two-dimensional map with an inherent ambiguity built into it, because the technology translates echo into image through a process that carries resolution limits and shadow effects and the particular visual vocabulary of acoustic data. The image of the Baltic Anomaly is clear enough to show a circular form with a raised perimeter and a central dome, and a long linear marking extending behind it. It is not clear enough to resolve the fine surface detail that would confirm or exclude any specific identification. It sits in that middle register, precise enough to generate claims and not precise enough to settle them, and that quality has sustained its life in the conversation about it in a way that a cleaner image might not have done. The structural situation the Anomaly occupies, documented but not formally investigated by a scientific institution, described by its discoverers in extraordinary terms and by marine geologists in ordinary ones, and visited by divers who brought back conflicting impressions and rock samples that the geology identified as unremarkable, is a situation that a particular kind of sustained cultural attention finds hospitable. Not every unexplained thing becomes a lasting object of this kind. The conditions that sustain it have to do with the visual distinctiveness of the sonar image, the accessibility of the discoverers to media, the readiness of the Baltic maritime imaginary to accept that the seafloor holds surprising things, and the structural gap created by the scientific community's decision that the formation did not warrant formal institutional response. A gap is not a conclusion. A gap is a space, and the cultural life of the Anomaly has lived in that space for more than a decade now, neither resolved into explanation nor abandoned. Lindbergh himself has described the object in terms that have shifted in register across the years. In the earliest media appearances, the language was more open. He could not explain it through standard geological reasoning. He had not seen anything like it in his Baltic sonar work. In later interviews, the framing is more measured, more careful about the distinction between what the sonar showed and what the sonar could establish. That evolution in his public presentation is consistent with what happens when a person lives with a discovery across years and absorbs the responses to it. The shape of what he knows and what he can claim has been refined by contact with geologists, journalists, skeptics, and the particular discipline of being asked the same question many times and finding that honest answers require more qualification than the first ones did. He remains the person who found the thing that has not changed. The decade-plus life of the Anomaly in media and online culture has produced something that functions almost independently of the object itself, a story about the Baltic Sea anomaly that is not quite the same as the Baltic Sea anomaly, a narrative version that has been shaped by each production and publication that carried it, each one making choices about which elements to foreground and which to hold back, which explanation to give the most time, which image to use in the thumbnail. The sonar image itself has remained constant through all of this, the same two-dimensional acoustic rendering, the circular form on the flat sea floor, the trail extending behind it, reproduced in black and white across every platform that has hosted the story. The image does not change. The conversation around it does. What the Anomaly has become in the mid-2020s is something like a stable node in the ongoing conversation about unexplained ocean phenomena, a case that is regularly returned to, regularly re-examined in new productions and new articles and new online discussions, regularly cited alongside other deep-water mysteries as part of the same broader question about what the ocean holds that has not yet been identified and explained. That position in the conversation does not depend on the case being scientifically unresolved. It depends on the case being interesting, and the Baltic Sea anomaly has remained interesting across more than a decade of scrutiny, in a way that speaks to something real in the original discovery, the genuine strangeness, to an ordinary working eye, of a circular form, with those proportions and that trail appearing on a sonar screen in the northern Baltic in the summer of 2011. The object on the seafloor has not moved. Whatever it is, the glacially deposited rock formation that the marine geologists described, the hardened sedimentary concretion that the geological explanations allow for, the thing that Peter Lindbergh's sonar found on a working summer day in the northern Baltic and could not immediately account for, it sits in the same place it has always sat, 85 meters below the surface of the sea, in cold water with very limited visibility and very limited light, in the company of the thousands of other objects that the Baltic seafloor holds in the particular cold patience of deep water. The Baltic does not have tides in the way that the open ocean does. The water there is relatively still at depth. Things deposited on the Baltic seafloor tend to remain where they are deposited, which is part of why the shipwrecks there are so well preserved, and part of why a glacial deposit from 10,000 years ago would sit largely undisturbed in the same position the retreating ice left it in, the sediment accumulating slowly around it across all the years since. 85 meters is not an impossible depth for commercial divers. With the right equipment and sufficient preparation, it is a difficult depth. Cold water, significant decompression requirements, very limited working time on the bottom before the ascent protocol must begin. The Baltic at that depth in the area of the Anomaly site is dark in the way that all deep water is dark, the surface light attenuated to near nothing by the time it reaches the seafloor. A diver's torch illuminates a small cone of the environment and leaves the rest in the particular darkness of the deep Baltic, not the darkness of a room with the light off, which carries the familiar dimensions of the walls and floor, but the darkness of open water at depth, which has no edges that the eye can find. The divers who went down to the Anomaly in 2012 moved through that darkness with their torches and their cameras and their sample containers, and what they brought back was rock and images that the cold and the low visibility and the limited working time had constrained, and impressions that differed from one another in the particular way that honest impressions of a difficult place in difficult conditions tend to differ. No diver has returned to the site since the 2012 expedition in any publicly documented capacity. The case is not active in the sense that an active investigation is active. No institution is currently conducting operations at the site. The Ocean X team's most recent public statements about the anomaly, as the documentary and interview record shows, have continued to describe the discovery and the dives without announcing new expeditions. The site sits in the northern Baltic, in the administrative condition of a place that has been visited once, in one relatively brief period of operational diving, with the results that are part of the public record and no subsequent activity to add to or refine what that record contains. That stasis is not unusual for cases of this kind. The anomaly is not unique in being a discovered feature that has not attracted the sustained scientific program that would resolve the question of its nature. The ocean floor globally is vast and very poorly mapped relative to its surface area, and the allocation of expensive operational resources for deep water investigation is a practical and institutional question that does not turn primarily on public interest. The Baltic seafloor holds features that have not been investigated in any sustained way, simply because the operational cost of sustained deep water investigation is high and the queue of unresolved questions is long. The anomaly is one item in that queue, and not the item that the scientific community has determined to be most urgently in need of the resources required to approach it. That is a practical, undramatic administrative reality, and it is worth naming as such. The image from the sonar, the one Lindbergh and Osberg released to the press in late 2011, the one that circulated across international news platforms within days, the one that has appeared in every documentary and article and online discussion since, is still the primary piece of evidence in the record. It has not been superseded by a higher resolution survey. It has not been replaced by a closer physical inspection that produced definitive photographic evidence. The rock samples exist, and their geological identification as volcanic basalt and granitic material consistent with Baltic seafloor composition is part of the record. The dive footage exists, and its limitations, the visibility, the cold, the constrained working time, are also part of the record. But the sonar image is what most people who have encountered this story have seen, and it is what most of the conversation about the anomaly has been organized around, and it sits in the public record as it has always sat, a two-dimensional acoustic rendering of a circular form on the northern Baltic seafloor, precise enough to raise the question, not precise enough to close it. The question itself is worth resting in without needing it to resolve. The Baltic Sea anomaly is a sonar image of a formation on the seafloor of the northern Baltic Sea, found by a commercial salvage team in the summer of 2011, visited by divers in 2012, described by marine geologists as most likely a natural geological feature consistent with the glacially shaped landscape of the region, and held by its discoverers as something they encountered and could not immediately account for through standard reasoning. That set of documented facts is genuinely interesting without requiring an extraordinary explanation. The ocean floor holds things that are unusual and ancient and structurally unlike what surrounds them because the processes that shaped it, glaciation, volcanic activity, sedimentation, the slow movement of water, and the occasional rapid movement of ice, are processes that produce a wide range of forms, including forms that look, in a two-dimensional acoustic rendering, like something other than what they are. The interesting thing is not necessarily that the anomaly might be something extraordinary. The interesting thing is that it is something, a specific object, in a specific place on the seafloor of a specific sea, and that the process of finding it and trying to account for it tells a story about working people in a cold body of water and the limits of what a sonar image can establish, and about how the world processes unexplained things when they appear. The story has settled now into something quieter than it was in 2011 and 2012, when the image was new and the possibilities felt wider, and the coverage was running across platforms in multiple languages simultaneously. The documentary productions and the online discussions continue, but at a rhythm that is slower and more settled, the conversation returning to the same documented material rather than being driven by new events. The anomaly has found the pace at which it persists, and that pace is calm and unhurried, the question returning in cycles the way that durable questions return, not with urgency, not with new evidence demanding a response, but with the particular persistence of something that the record has not closed, and that the cultural imagination continues to find worth returning to. In 1,000 years of Baltic maritime history, the seafloor has been the site of documented events, the sinking of ships, the deposition of cargo, the settling of hulls into cold sediment that preserved them across centuries. The anomaly is one formation among many that the seafloor holds, distinguished from the wrecks by its uncertain origin and from the surrounding geology by the visual impression its sonar return made on a working survey team in 2011. It is distinguished from the rest of the sea's undiscovered contents by the fact that someone did find it, did release the image, and did sustain a public conversation about it across more than a decade. Most of what the Baltic holds on its floor has not been found and will not be discussed. This one thing was found, and the conversation about it has continued, and it sits now in the documentary record as a place that was visited, a question that was raised, and an answer that was not fully arrived at. The surface of the northern Baltic Sea, in the area above the Anomaly site, looks like the surface of the northern Baltic Sea. Everywhere else in that region, gray and flat in the overcast light that characterizes the area for much of the year, occasionally lit differently when the sun is low and the angle is particular, moving with the slow currents and the mild wave action that the Baltic's relative enclosure produces. There is nothing to see from the surface. The water above the site is 85 meters deep, and the formation is at the bottom of it, and the surface gives no indication of what is below. Ships pass across it, the water moves across it, the light comes and goes across it. Below it, at the depth where the sonar pulse once returned a circular echo that a working diver had never seen before, the thing sits in the sediment in the cold dark and the particular stillness of deep Baltic water, as it has sat since whatever process deposited it there was complete. The case file, if there were a case file, would have no final entry. The institutional scientific response did not produce a formal investigative record. The assessment was informal, offered through public commentary, and did not require a document that could be closed. Ocean X Team's operational record closed with the 2012 expedition. The media record is ongoing in the sense that any story that continues to be covered continues to generate new entries, but the entries are repetitions and reconsiderations of the same documented material rather than additions to the evidentiary base.